guys, so today we will start our chapter 3, week 9. Shear strength of soils. Here our program outcomes PO1 and also PO2. Our course outcomes CO1, CO2, COPO mapping, CO1, PO1, CO2, PO2. Learning outcomes for this topic. At the end of this lecture, students should be able to understand the procedure and determine the shear strength parameter for shear box. Number 2, understand the shear strain relationship. Alright guys, determination of shear strength parameters of soil. So parameters. So for using consolidated drain test, for total stress, we will get the C and phi. C is cohesion and phi is angle of friction. Okay, for consolidated drain test, this one we will get the effective stress. So we will get cohesion effective and angle of friction effective. Alright, now, most common laboratory tests to determine the shear strength parameters are, first is shear box test or direct shear test. Number 2, triaxial shear test. Other laboratory tests include unconfined compression test, or we call it as the UCT, laboratory vane shear test, and also torsional ring shear test. Okay, but unconfined compression test is one of the popular tests. Alright guys, now we go for the shear box test. The test is quick, it's fast and inexpensive test. It is used to determine the shear strength parameters for both cohesion and cohesionless soil. It's also used for consolidated drain test. Okay, the test is also known as direct shear test because the normal shear stress on the failure plane is measured directly. Look at this figure. Alright, if you see here, we have the N value. This is the normal stress. Okay, as is, this one is for shear. Alright, so we apply normal load or normal stress and also shear stress to the soil sample. Right? Shear box test. The test equipment consists of a metal box in which the soil specimen is placed. The box is split horizontally into two halves. Okay, so this one is 1, this one is 2. Alright, vertical force, or we call as the normal stress, is applied through a metal platen. Alright guys, this one is normal stress. Alright, and then shear force is applied by moving one half of the box relative to the other to cause failure in the soil specimen. Alright, look at this. This is the shear stress applied. So what happens is, when you have the normal stress and also shear stress, what happens is the soil will move. Alright, the soil will fail and shear. Alright, and then you can look at this YouTube channel how the test is conducted. Alright guys, look at this. This is a shear box test for sample under normal load. Before shearing, okay, we only apply the normal load. Okay, here is loading plate, and then this is your soil sample, and then you apply the load at the top as a normal load, and then after that, sample. This one is sample under constant normal load at increasing shear load. So we apply normal load and then we apply force here. And then what happens is the soil will fail because of the shear load. Alright, we shear the soil, right? And then we have also the normal load at the top. Alright guys, this is the preparation of the sand specimen. Okay, we have the porous plates. Alright, so we have the porous plates, and then this is the box, and then this preparation of the sand specimen, how we prepare the specimen. Look at this. This is the specimen, and then this is the sample. Alright, so guys, so firstly we put a sample, and then what we do is we leveling the top surface of specimen, and then after that we will place the pressure plate at the top of the specimen. So the specimen preparation is completed. And then after that we will place the specimen here. Alright, this is the shear box. Then we have the probing ring to measure the shear force. And then we have the dial gauge to measure the horizontal displacement. And then we have the loading frame to apply the vertical load or normal load, normal stress. Alright, this is the dial gauge to measure vertical displacement. Alright, this is all important component for the shear board test. Alright guys, this is a schematic diagram of a shear board test. Okay, first we have screw here. We have the Spartan screw, and then we see here we have a soil sample, and then it's divided into 1 and 2. Alright, so at the bottom is the porous stone in drain test. Porous stone here, and then we have the normal lip applied at the top, applied by hanger and lever mechanism. So we apply the normal load here, and then at the right hand side, this one is shear load, measured by probing ring or cell load. Alright, so what we do is apply the normal load at the top, and then after that we will apply the shear load for horizontal here, and then we will shear the soil, alright, until it's filled. Alright guys, this is analysis of test results. Okay, this one is normal stress. Okay, so normal stress is equal to normal force divided by area of cross section of soil sample. So this is your sample, for example 60 mm times 60 mm. So the area is 60 times 60 mm. Alright, so cross sectional area. Okay, this one is shear stress. Shear resistance developed at the sliding surface divided by area of cross section of the sample. Okay, or shear force at the horizontal. This one, shear force horizontal. Normal force is vertical, right? Alright guys, now we look at the shear stress strain relationship. Okay, first we have the normal stress and also shear stress. Okay, so now we look at the shear stress and strain. Okay, when we apply the shear stress, it will increase. We apply the stress, the shear value will increase, and then it meet the peak, and then the value will start to drop after it meet the optimum value of shear stress, and then it fail, so it will drop the value of shear stress, and then okay, and then you see here the shear displacement or strain. Shear stress versus strain. Strain usually in mm. So when you apply the shear stress or shear force, what happen is there are displacement for your sample when it's fail, right? Alright guys, in dense sand, the grain are interlocked. Okay, in dense sand is interlocked, and initial expansion or dilatation is necessary in order that shearing can occur. Thus, shear stress will first rise sharply with corresponding increase in volume. As the interlocking is reduced, the shear stress falls back and finally level off at the ultimate value. Alright, for the loose sand, okay, this one is for dense sand and loose sand. For loose sand, volume decreases and the soil compress or contract into a more dense state as the shear stress increase toward the same ultimate value. Alright guys, look at this shear board test on sand, how to determine the strength parameters, cohesion and also angle of friction. Alright, so look at this. This is shear stress versus shear displacement or strain. Okay, so when we apply the horizontal stress, or we call as the shear force, okay, what happen is shear stress will increase, and then the shear displacement is also increased. And then after that, the soil is failed. So what happened is the value of shear stress will reduce, and then alright, and then the displacement is continuing. Alright, so this one is, we have for example, this one is normal stress. Which one alright, so this one is for normal stress 1. Alright, and you have shear stress 1 here, shear stress 1, and then we have normal stress 2, normal stress 2 here. Right, normal stress 2, and then we have the shear stress 2, and then we have another normal stress, okay, normal stress 3 here, and then we have the shear stress 3. Alright, so how to draw the shear stress at failure? Alright, so first is we have to know the peak value here, peak value for each test. Okay, we take the each value, the maximum or peak value of shear stress. Alright, and then shear stress versus normal stress. So you have to plot shear stress versus normal stress. Alright, and then after that you will get the angle of friction. Okay, and then also the C value for this. The C here is 0. Okay, you have the angle of friction in degree. Okay, so first is you have to draw, or you have to plot the point for shear stress versus normal stress, and then you will get the best fit or straight line from the point. Alright, and then after that you have to determine the value of phi. Okay, phi is angle of friction here. Alright, this is some important facts on strength parameters. Phi here, phi, and also C of sand. Sand is cohesionless, so means that C is equal to 0. Direct shear tests are drained and pore water pressure are dissipated. Hence, U is equal to 0. Therefore, phi prime is equal to phi. C prime is equal to C. This one is phi. Okay, angle of friction. Alright guys, look at this. This is a shear bulk test on clay. Alright, in the case of clay, horizontal displacement should be applied at a very slow rate to allow dissipation of pore water pressure. Just one test would take several days to finish. Alright, so it says that this one is a clay, over consolidated clay. Alright, so first you will get the value of C. C is going to be more than 0. Then you also have the angle of friction value here. Right, this one is normal force and this one is shear force. So more column failure envelope, you have to draw the shear stress at failure versus normal force. Right, so you will get the value of C and phi. Alright, so now we look at the advantages of using shear bulk test. First, shear and normal stresses measure directly. So we will measure the stress and normal stresses. Okay, direct. Number 2, normal stress constants. Normal stress constant throughout the test. It is also an easy method for sand and silty sand. The volume changes are easily measured, and using a reversible shear bulk, large displacement can be achieved, thus enabling measure of residual strength. Alright guys, however, there are disadvantages of using shear bulk test. First is the distribution of shear stress over the plane of failure is assumed to be uniform. But in fact, it is not uniform. Okay, so we just assume. Number 2 is not possible to control drainage from the sample or to measure the pore pressure within the sample. Therefore, we only get the total stress measurement. Alright, we cannot get the value of effective stress. Alright, another one is normal stress cannot easily be varied during the test. Alright guys, look at this. This is example, right? Example for direct shear bulk tests were performed on dry sandy soil. The size of specimen was 50 mm times 50 mm times 20. Alright, so means that the size is 50 times 50 and the height is 20 mm. Alright, the tests were given in the table. So first look at this. Right, look at this. You have the normal force. Okay, normal force is given here. And then we have to determine the value of normal stress. The normal stress is equal to normal force divided by cross-section area 50 times 50 mm. Alright, 90 over 50 times 50 mm, so you will get 36 kilopascal. And then this one is shear box value. So you have this one is shear force. Okay, so you have to determine the shear stress. So similar to the normal stress, shear stress is equal to shear force divided by cross-sectional area. So means that 54 divided by 50 times 50 mm. So you have to convert to the kilopascal here. Alright, so this is example. Okay, you may refer to the example here. Alright, this one is for normal stress. This one is for shear stress. And then after that, you have to plot shear stress versus normal stress. Okay, so for example, you get 1, 2, 3, 4 point. And then what you do is you have to draw the straight line, the best fit straight line. So after that, you will get the value of phi. Alright, so the value of phi, angle of friction. And for this example, C is equal to 0. So angle of friction is equal to 31 degrees Celsius. Guys, great things never come from comfort zones. Good luck, guys.